Hello everyone, welcome to this video. In this video, we will be discussing two most important concepts. First, we will begin with the tracing. Then we will discuss about middleware. For any application, tracing or observability plays a very crucial role. Especially in AI, there are quite a few things that you want to understand or observe, right? In the context of AI agents, there are four things that we will observe. First, we will be observing the overall performance. So here we will say like how much ever seconds it took to complete the overall execution. Then we will come to the cost part where like we will see how many tokens are used. Then we will see how exactly the execution happened, like step by step. So if at all you wanted to see like what has happened throughout the execution, you should be able to observe that. Then using this you can also do additional debugging, right? For instance, a function it's a called with a specific value, so you wanted to trace all this information so that you can backtrack. So in summary, observability let you understand why it's set, how fast it's set, and how much it costed, right? Now let's go to the Visual Studio Code and see how do we implement this. So this is how we implement the observability. So before we try to understand the implementation, let's go up a bit here. So the Azure AI framework uses something called OpenTelemetry, so that exposes the span. So span, if you try to understand the span, it will be something of this sort. If you see here, it has a trace ID and a span ID. So the difference between the trace ID and the span ID, trace ID it's unique for the execution, wherein the span ID it's specific within that sub execution. Say like you are asking, hey, what is the weather in Tokyo? So you will have one trace ID for the entire execution, wherein like the span ID, LLM execution will have its own span ID, and the function calling will be having its own span ID. So think of this way: you are sending a courier, the courier has a trace ID, the courier number, and the courier goes to different locations. So each location has the location ID. Span ID it's something close to that location ID, and on top of that you will have the location name, when it received, when it moved forward, how long it waited in that particular location, status, whatever is that, it has all this information, right? So basically now what we have to do is that we have to enable the application to send the trace, and when it sends out the trace, we should be able to collect the trace and store the trace in a format that we are interested in. So that's what we are saying here. So we are saying like, hey, start the observability. So basically like shoot out the trace, and somebody needs to catch. So that is where like we are using this collector. So if you look into this collector implementation, import the span exporter, and it has couple of methods that you need to extend to. So basically now you know the structure, and using these specific implementation, you should be able to extract the information from a trace, and you should be able to store the information as the way you wanted to have it, right? So otherwise the code will be pretty same. So here like I have couple of functions: get weather, calculate, search, or whatever is that. So now that's all, you don't have to do anything else apart from these 3-4 lines, right? So here I started the trace, and I mentioned that, hey, you have to use this trace provider. Trace provider will have two different components: one is the trace resource, other one is the trace collector. uh, Basically the telemetry collector, right? So here I'm using a batch span processor. So instead of sending each and every span, I will be sending the spans as a batch to this particular collector. Now the collector will get all the span information, and then whatever I have configured to do, like in my case, I will be writing all the logs into the text file. It can be a text file, it can be a database, or it can be anything. You should be able to send the data to the trace exporter. From a trace exporter you should be able to uh, send the data to wherever you want to have in a format that you wanted to have it, right? That's it. Now let me go and run it. Now let me go and run this. So now the question I will be asking here: what is the weather for Paris, right? So now let me go and ask. So if you think of this one, right? So first I'm sending a question to the LLM. I'm asking what is the weather for Paris. Now LLM will be getting this input, and then like it will get to know that, hey, like I need to call a weather tool for a city called Paris, and then like it will make a call to the tool, that is iteration 2, and the function will return the response back to the LLM. LLM will receive that information, and this is going to be the second input to the LLM, right? Now it is going to finalize the final outcome, that is iteration number 3, and the like it is going to print the result, right? So there are 4 steps we are going to perform: the initial input, and the like function called results will be sent back to the LLM. Now LLM needs to finalize that, and then like finally we will be printing all this information. So now if you see here, this is how it is going to generate a log file for me. So as you see here, first it started with the GPT mini. So this is my initial costing, so for which it spent about 4,600 milliseconds. Then second iteration, it made a call to the tool with all this information. Means if at all you wanted to even capture further information, you should be able to do that using the span exporter. Now the LLM will receive the response from the function. It needs to make a or finalize the final outcome. Now finally we will be printing the telemetry bot, in the sense like it is the outermost wrapper. So it is just going to print all the data for me here. So it says that the overall execution took about 7,000 milliseconds, right? And these many input tokens or the output tokens are used, all those information. Now I have the complete information, right? So I will get to know that, hey, like initially, like the user query, LLM received the user query, then get made a call to the function, get weather function. Though I have couple of functions, it made a call to this particular function. Now LLM received that input from the function. Finally it responded back to the user, and this is how much time it spent, this is how much token it has used, all those information. Now using this data, like this log, I will get to know the complete execution, right? So that is the beauty of this observability. Now let's go and talk about another most important topic called middleware. So before we try to go into the implementation, now let's try to understand what is this middleware it's all about. So remember, like with the observability, we are able to understand the complete program execution. However, like we won't be able to control the overall execution. With middleware, you should be able to control the execution as well. Middlewares are also known as interceptors. So there are 4 interceptor: timing interceptor, security, and function, and token cost. Coming from a .NET or a Java background, middlewares are nothing new to you. Let me try to explain. So let's assume that user is providing an input. First, it will go to the timing middleware. In my case, I'm just starting the clock. However, like you can do whatever you want to do. Then it will go to the security middleware, where like I will be checking the content safety. Then it will go to the chat middleware, basically like before the user input submit to the LLM, it will go to the chat middleware, where like you can try to reduce the token, right? So user it's saying some providing some input, you really don't have to submit as it is. You can try to reduce or to minimize the token, right? So that is what you can do it in the chat middleware. Then you will submit the refined query to the LLM. LLM will see if it needs to execute a function. So at this point in time, the first execution, first iteration kind of are done. So at the time, like it will go back and tell the chat middleware that, hey, like my execution, first execution, it's done. Then at the time you can print, hey, like in the first iteration, the LLM consumed these many input token, these many output tokens. Then it will make a function call. So in the function, when you make a function call, the function middleware get triggered. You can uh, extract the information, like what is the function name, what are all the parameters are passed, all those information. And if at all you wanted to modify something, you can very well do so. And then like you can make a call to the function, and the results will be passed to the LLM. Now this is going to be iteration 2, right? So before it again goes to the execution, it will again call the input the chart middleware, where like again you will capture all this information like a token and try to reduce the overall input content, right? Finally the LLM execution will get finished, then it will again go to the security middleware and the timing middleware. Only one caveat with this approach is that whenever you use a async operation, so let's say like most of the scenarios we will be using async, right? We will not be using the just the run method, rather like we will be using async run stream. So in that case the timing middleware will get called, security middleware get called, and the like this chart middleware, even before it come to the execution, these two middlewares will get executed, like the overall execution cycle will be completed for the timing and the security middleware, right? The reason is that rest of these will be asynchronous. So that is in such a case you cannot expect the flow one after another, rather like a timing and the security will get finished, then rest of the flow will continue, like chart middleware and the function middleware will get invoked, depends on the need, right? But the like end of the execution you will not see the timing middleware and the security middleware, it will get completed in the very beginning itself, right? So now let's see, like let's try to simulate this. First I'm saying like tell me a simple tell me a joke. It's pretty simple chant, right? First we will trigger that timing middleware, then the security middleware, then LLM, right? So before go to the LLM, the chart middleware get called, the LLM execution will happen. Once the after the execution, the again the chart middleware will get called. Then finally we will have the result, and finally we are expected to have a timing middleware. So the in case of async you will not see the timing middleware at the end. The reason is that in this entire portion it's going to be async, so the control will leave from the main thread to the subordinate thread. So you in that sense, like the main thread execution, it's already kind of a completed. So now again let's try to see in case of a tool, the timing middleware get called, a security middleware, then in the LLM middleware or a chart middleware, then function middleware will get called, where like we will be capturing some of these information. So remember, like as a demo I'm just capturing this information, however like it has the capacity to do anything that you wanted to do, right? You can change or you can control the input or whatever you want to do, you can very well do that. And the security block, so in this case, like what is my password, I'm just saying. So the middleware, security middleware detects that this is not allowed. In that sense, like it will just come out of the overall execution, right? Now let me go to the Visual Studio Code. Middleware implementation involves three different portions. First you need to import the relevant classes. In this case, I have imported the agent run context, the function invocation context, and the chart context. The timing and the security will be using the agent run context, and the function middleware you will be using function invocation, and the LLM middleware will be using the chart context. That you need to define the middleware. I will come back in a moment. So if you see here, I have defined all these middlewares here, all these four middlewares. Then you need to reference those middlewares in the agent definition. So if you see here, apart from the regular instruction and the tools, I have also included all four middlewares here. Now let's go to the implementation here. Implementation, it's a pretty straightforward. If you just see the timing middleware, it takes the agent run context and it starts the timer and prints some information and calls the next middleware, right? So next middleware will be the security middleware. So if you just go here, it also takes the agent run context, and if you just come over here, it checks all the messages and especially looks for these particular keywords. If there are any keywords matches in that message, then it is going to say that the context will be terminated, the execution will not be continued, otherwise the execution will continue. As this is just a demo, like this is, I kept it very simple, but then like how in terms of enterprise application, you will be using the content safety service. Then we have the token counter or the LLM middleware or a chart middleware. So if you just see here, it prints the input tokens, and the like at the end it also prints the output token. So what you can do is that instead of just printing the token, estimated token, what you can do is that you can somehow reduce the input, right? So just removing the unwanted tokens, you can remove all of those, just pass the relevant information to the LLM. That way, like, you can definitely reduce the overall input token, as well as you can also try to reduce the output token. That is something that we can do. Then we will have a function middleware. It takes the function invocation context, it prints all this information, right? So you see, if you want to extend some additional, if you want to pass some additional information, you can very well do it through this middleware. So that's about the definition, and we discuss about the registration as well. So now let's go and try to run the Python program here. So let me go and run the program. Let me maximize this. So I have provided some predefined prompt here. So let me copy this. So the first one, it will be calling the using the timing and the token counter, right? So just goes here. It says that it started middleware security middleware also called. There is nothing, so there is no sensitive, and it passed. Then it called the the input it's sent to the LLM. Before the LLM executes, the chart middleware gets called, and we see the result. So if you see here, the timing middleware and the security middleware, it's completed even before the chart middleware gets called, right? The reason is that we are using run stream here. So if I just come over here, we are not using the synchronous execution, rather this is a synchronous execution. So if I just come over here, here we are using the asynchronous. So the main thread will not be waiting, and that's why, like, this gets completed even before the actual program completes, right? You can very well tweak this. I'm not going to spend a lot of time here. So now let's move forward and try to provide a next prompt here. So now let's say, like, what is the weather in Tokyo? So in which case it is going to make a call. So first the user question, and the function LLM will decide it needs to make a function, and then it makes a function call, and finally prints the result, right? So now let me uh, provide the input here. So the timing middleware started, security middleware started, timing middleware completed, chart middleware started. It found that it needs to send a message to the function. So you see here, now the function gets called, the function middleware gets invoked, and then, like, finally the chart middleware gets called. The reason is that the function returns this value, and then the same value will be passed to the LLM. Now LLM will be finalizing the final outcome. So that is what you see here. So that is how it works. Now let me also provide one more prompt here. So now let's also try the calculator here. So in this case again, so if you see here, timing middleware started, and then it says that it needs to call the get time and calculate. Two functions get called, and you see all of this information. So whatever it's passed, all of these you can find it from the logs here. Now let's also try to pass to some security related query here. So okay, now say, like, what is my password, right? So now if I say this, so it is just going to it goes to the security middleware block the execution. Now we are done with the that particular request, right? Now let's see what do we have. So what search for user and get the weather. So this is again going to be all four middleware. So search for users. So first timing middleware, again security middleware, then it calls the functional middleware to search for the database and get the weather information. So that's how you can use the middleware, just not to capture the information but also control the overall execution. So now in this video we discussed the most important two topics, observability and middleware. Now in the next video we will be discussing about MCP. That is going to be a lot more interesting. Thank you for watching.